Hi, this is Kevin Trainer. Welcome to my lecture on Chapter 8 of Interaction Design 4th Edition. Chapter 8 is entitled Data Analysis, Interpretation, and Presentation. Our goal here in the chapter is to discuss the differences between qualitative and quantitative data and analysis. We'd like you to be able to analyze the data gathered from the kinds of activities we talked about in the last of the chapters, questionnaires, interview, observation studies. We want to make you aware of some of the software that you might be able to use in your analysis, identify common pitfalls in data analysis, interpretation, and presentation, and enable you to interpret and present your findings in appropriate ways. So this is definitely a survey course kind of treatment here. If you were in a doctoral program, for instance, you'd be spending a lot more time on research methods and all these kinds of things. This is enough to get you oriented and keep you out of big trouble, I think, and give you some hints about how you might use this kind of analysis activity in your project and in your work. So let's begin by trying to distinguish between quantitative and qualitative. So quantitative data are expressed as numbers, and qualitative data are expressed otherwise. So they're difficult to measure sensibly as numbers. So for instance, there's an example in the text where they talk about qualitative information. They had responses to a questionnaire, a question, and it had to do with the dissatisfaction of the subject, and one idea was just to count the numbers of words in the responses, with the idea that perhaps people who were more dissatisfied would say more and people who were less dissatisfied would say less. And it was suggested that maybe that was a naive way to do that. In quantitative analysis, we use numerical methods to ascertain the size, the magnitude, and the amount of the phenomenon represented by the numerical data. In qualitative analysis, we use schemes such as themes, patterns, and stories to express the nature of the elements we have found in the data. So, generally speaking, it's the point of view of our chapter and our authors, you have to be careful the way that you manipulate your data and the way that you draw conclusions from them, because, it's pretty easy to get into unreliable territory. Okay, so here we have a slide where we're talking about simple quantitative analysis. And most of us are familiar with that. So a typical thing that we do with quantitative data is we look at things like averages. As they point out in the text, the word average has more than one meaning. The most common is the mean, which is you add up all the values and you divide them by the number of the data points. We also have the median, which is the middle value of the data when they're put in a ranked order. Or we have the mode, and this is the figure that appears most often in the data. Okay? Now, in a typical distribution of data, the mean, the median, and the mode are three different statistics. I mean, they might happen to have equal values in an unusual data set, but in a typical data set, they're different. One of the things that we do often is that we describe things using percentages to show trends. So we would like to be able to say that 80% of the people who responded to our survey said that they liked product A over product B. I think there's some really good warnings within the text on how when you really have a small sample size, the percentages are misleading, right? So if in fact we had four of five people who responded to the study preferred product A over product B, well, that has some significance. But it's sort of weak in terms of numbers of observation. But let's say that 400 out of 500 preferred product A over product B. Well, then making some kind of claim like 80% of the people who we surveyed preferred product A over product B. Well, that might be less misleading. Okay? And what we don't want to do, we don't want to mislead. Okay? First of all, that's going to perhaps lead the people who are consuming our information to take actions that are not warranted. But two, more knowledgeable people are going to expose our work as unreliable, in which case the demand for our services is going to be diminished. So I don't think we want either of those to happen. And of course, on the bottom of the slide, we have three graphs. Let's see. On the left, we have a scatter plot. In the middle, we have a pie chart. And on the right, we have a bar graph or histogram. And there's some pretty good examples of these in the chapter for your review. Here on slide 5, we have an interesting example of using graphing techniques to visualize data. And there was a study described in the chapter of a massive I forget what they're called, MMPs or whatever. This is really so different from things that I do that I forget what the acronym is. But it's a role-playing game where you go places and you exhibit behaviors, and you can observe the behaviors exhibited by others, and you can interact with others either through gestures or through utterances. And what they did is they logged the location and the activity of the participants over a fairly long period of time. And they, as I recall, they analyzed two locations. One was the cantina, and the other one was the Starbase. Okay, that's what's coming to mind. And what they're trying to show here is the relationship between gestures made and gestures received, such that not only do we have data points, but what we see is we see that the observations have a kind of a circle size, so that That's the magnitude of the data at that intersection of the axes. So of the data points that we can really see, there's a really big bunch of a really big number of observations that are about at a little over 4 on the x-axis and about 11 on the y-axis, right? And here is another one. This is at the starport. So this is the starport, and the other one was at the cantina. I was right about that. Okay. And we can see that there are some really big pools of observations down by the origin, down by 0, 0. So it looks like we had a lot of data with very low interactivity. And then we almost have a trend. You can see kind of trends that go up, right? So these are interesting data visualizations. And I thought there was an interesting discussion on one case, not about the gestures, but about the utterances. And one of them had to do with the ability to program your avatar to make utterances even when you were not actually participating in the game. And how that led to different behaviors in the people who potentially interacted with avatars that were essentially faking the presence of someone there rather than actually representing the active presence of the person. So these are some really interesting data visualizations. This is almost three-dimensional in the way that they're trying to represent the data. Okay, they also talked about web analytics. And web analytics are quite interesting. Some of the considerations that were talked about were the fact that you don't always get the same statistics from different web analytics packages. Also, I think there was a really good discussion of the different ways in which you could show the results, right? So I thought that was pretty interesting as well. Okay, now quantitative analysis is something that most students are fairly familiar with. Okay, because we start to talk about things like this early in our math education. So we start to talk about the mean, the median, and the mode, and we even might talk about other descriptive statistics like standard deviations and all those kinds of things. But so the quantitative stuff is pretty straightforward, not surprising. But it's the qualitative stuff that is new to many students. And of course, it's the qualitative stuff that's pretty important for social science research, of which human-computer interaction is one of the is the important practice area of social science research that we are interested in. So, in simple qualitative analysis, we might be looking for recurring patterns or themes. Okay, so we want to look at the data, and we're hoping that some kind of pattern or theme is going to emerge from the data. Okay. It might be dependent upon the observation framework that we used. We also want to categorize data. So categorization schemes might be emergent, which is to say we might look at the data and say, we see some trends here. Let's try to categorize those. Or we might have the categories ahead of time. That would be our pre-specified. And the other thing we might be looking for are things that are critical incidents. Okay, so we might be looking through the data and try to find phenomena that particularly stand out as significant key events that we want to be able to characterize in a useful way in terms of our findings. So what kind of tools might we use to support data analysis? Well, one of the nicest things about our day is that the simple spreadsheet tool is pretty darn powerful. Okay, so I remember when I first went to a graduate school, I hate to admit this is before electronic spreadsheets, but it's true. So the statistical tools that we used at that time were all purpose-built. In fact, one of the tools of the day is the next thing on the slide, SPSS. And there were other competing tools and all of those things. Electronic spreadsheets came along, and pretty quickly people started to put statistical analysis or data analysis tools into the products. So now a product like Excel is pretty good at doing some fairly sophisticated data analysis, and you'll see researchers who are doing all their analytical work on spreadsheets. And then we have statistical packages, and there are a number of them. One really interesting open source one is called R. Okay. One that's been around for a long time, it's been around for a good 40 years or more, is SPSS, which initially meant Statistical Package for the Social Sciences, and now I think means only SPSS. There are a couple of qualitative data analysis tools as well. They might involve a categorization and theme-based analysis, or quantitative analysis of text-based data. And on the categorization scheme, I had in my work at the Informatics Research Center, two of the tools that we're using are the ones in the fourth bullet here, NVivo and Atlas TI. And these were two alternative tools, each with their strengths and weaknesses, that allowed you to take your qualitative data and mark it up in a way that allowed you, one, to categorize the data, but two, to be able to go back and see where your data have come from. Okay, so for instance, you might be taking a transcript and marking up the transcript, right? So if you want to go back and look at your data, you can actually go back and find the observations where you marked up part of your transcript with a particular category, for instance, that you used in your analysis. The book points to a website, which I must say I don't have a lot of experience with, but I always like resources. There is a project called CAQDAS, based at the University of Surrey, that has a pretty extensive, which is a pretty extensive resource on these kinds of tools. Okay. So in addition to tools in this qualitative area, one needs some theory, some framework. Okay. Because well, why do we need some theory or some framework? Well, we need something that has some rigor in between the data and our conclusions. And if, in fact, we build the apparatus of our analysis around one of these theories, or some combination of them, it gives us a rigor that makes our work more research-oriented and less kind of anecdotal. Okay, one of the potential problems is you can take a lot of this qualitative stuff and thinks it would be like analyzing the answers to open-ended questions on a survey or an interview, or having somebody do essentially walk and talk, where they voice their thoughts as they work with your tool, work with your product. So what we don't want is to just have sort of anecdotal observations. Okay, we want something more robust than that. And these frameworks are the kinds of things that give us those kind of qualities that we're looking for. So 3 that we talk about that are very popular in social science research. A really important one is grounded theory. It's used in a lot of social science research of all kinds, including human-computer interaction. Distributed cognition is a framework that we mentioned a few chapters ago, which is very popular in interaction design field. And activity theory is probably less popular, but interesting, and came out of Russian psychology theory that began in the 1960s. So let's talk about grounded theory. Grounded theory aims to derive theory from systematic analysis of data. It's based on a categorization approach, which we call coding. So when we have some kind of a phenomenon that we see in our data, again, typically our data is, well, you can think of it as a text, right? I mean, it could be a text, it could be somebody's written response, or it could be a verbal response to an interview which we transcribed, or it could be some kind of talking that went on during some kind of a video when they used our product, and we could have transcribed that as well, right? And then what we need to do is we need to pick the parts of that text, and we need to code them. All right, we need to categorize them in some way. And in grounded theory, we've got 3 levels of coding. We've got open coding, axial coding, and selective coding. Okay, so in open coding, we are identifying the overall categories. In axial coding, we are fleshing out and linking categories and subcategories to each other. And in selective coding, we're trying to take these coding elements and to weave them into some kind of a theoretical scheme. So researchers are encouraged to draw on their own theoretical backgrounds to inform the analysis of the data. And the grounded theory approach is probably the one that was used the most frequently in the informatics research center where I worked. And I've got to say that, and not having come from this kind of background myself, my initial thoughts were to be skeptical of this kind of approach, where you just you go into these data and then you start categorizing them, and when you start, you, at least in theory, have an open mind. In the end, you have a coding scheme for the data that supports your theory of the behavior that you're trying to analyze. And really seeing it in practice was, for me, just what I needed to see. I mean, I was a worker on one of the studies, and I was sort of a project coordinator associated with another 2, so I got to see their work. And the artfulness of this is certainly important as you're creating the categories and doing the coding. But I really did feel that in each of the cases, as I looked at the data and I looked at the theories that emerged from the data, and I understood the coding, it made a lot of sense to me. I mean, it was I was won over by this grounded theory approach, which, as I said before, I was a little doubtful about when we started. Here's a code book. Okay, so here's a code book used in grounded theory analysis. This particular one was in talking to citizen scientists. So this is a clear kind of informatics research that was going on. The important thing in coding is that you need to be able to create what we call intercoder reliability. So we need to make sure that we have set up the categories and the schemes such that they're obvious enough that your coders are interchangeable. Because typically we have enough data that they're not all coded by the same person, right? And so having a code book is a tool in promoting intercoder reliability. Okay, and here we have one of the illustrations that we had in the text, and we're showing axial coding. So here we're not only showing categories, but we're showing subcategories, and we're showing their interrelationship. Okay, so off of grounded theory and onto distributed cognition. So again, a few chapters ago, we talked about distributed cognition as an analytical approach. So the people, the environment, and the artifacts are regarded as one cognitive system, right? It's used for analyzing collaborative work, and it focuses on information propagation and transformation. So in distributed cognition, that's the last of this. So we're trying to look at a system, a behavioral circumstance, I guess, and we're trying to categorize things by saying, okay, the information is collected by a person. This particular person, perhaps in a particular job role, they're working in a particular environment when they do it. They take that information and they record it in some kind of artifact. Perhaps it's a report, perhaps it's a recording, and then they pass it on to someone down this information chain who has to act on it in some way. And perhaps when they're acting on it, they're in some other environment that we need to note. Perhaps they take that information and transform it into some other information artifact. And what we want to do is we want to kind of understand all the steps of this process and the people, the environments, and the artifacts involved. And there's always this kind of idea that perhaps there's a problem that we're trying to understand, right? So we're looking at this kind of systematic activity, and perhaps there's a breakdown somewhere, and we want to kind of understand that in a way that we'll be able to act on in the next phase of our work. Activity theory is pretty interesting stuff. It explains human behavior in terms of our practical activity in the world. It provides a framework that focuses analysis around the concept of an activity and helps to identify tensions between the different elements of the system. Two key models make up activity theory. One outlines what constitutes an activity, and one models the mediating role of artifacts. So again, this version, which I call the Engstrom version, here on slide number 17, I think you get the idea here about all that's going on. I'm always impressed by how abstract all this is. We're trying to take the particulars in the environment, and we're trying to assign them to something from the model. And here in the Engstrom version, we have a tool, we have rules, we have division of labor. Those are all somewhat environmental. We have the subject, we have the object, we have a community, and we have a transformation process, and then we get some kind of outcome. So I find this approach, this activity-based approach, both really appealing and somewhat disappointing as well. It really appeals to the kind of the abstract modeling kind of point of view that I've been drawn to really throughout my career. On the other hand, we have a lot of constructs here that have a pretty tenuous relationship to things that we can actually see, hear, and read. So whereas I think it's a promising theory, and the models here are promising, the authors admit that it's not widely used, and I can imagine that it's not widely used because it's kind of thought heavy, I think I would have to say. Now, if we back up here, we'll see there's another model, the more traditional one before the Angstrom one, where we've got two sides to it. One, activity, action, operation. The other one, motive, goal, conditions. But it just occurs to me, and I have to be honest here, that in terms of the kind of interaction design that we're going to do in the field, that this is maybe a bit thought heavy for us. But if you're impressed and you want to dive in, far be it from me to stop you. Presenting findings. So I think there's a real good discussion in the text about how to present findings. They talk away, for instance, that we might want to begin with summaries. They talk about the power of story-like elements in the presentation. There's a lot of good tips, I think, that make a lot of sense. And then within that, here are some of the points that they make. Only make the claims that your data can support, right? If your clients would like to guess beyond that, well, certainly they're entitled to. But you want to make sure that they know the difference between what your data support and what further guesses might be made beyond that. Okay, we shouldn't be in the guessing business. The best way to present your findings depends on the audience, the purpose, and the data gathering and analysis undertaken. So there's no one good way to present it, and I think they have a good discussion of what some of the elements are. Graphical representations may be appropriate for presentation. So certainly we just don't want to show people either the initial data, which would be, recordings of interviews, videos, all those kinds of things. And we want to show an excerpt so that people understand where all this stuff came from. Likewise, if we turn this into a bunch of, if we coded up the stuff, and turn this into a bunch of observations, I'm not sure that people would really like to read through our detailed tables of the data. But some kind of summarizations of them they are interested in, and perhaps they'd like to be able to refer to detailed versions of the data, which might be in some kind of appendix, for instance. Other techniques. Rigorous notations using stories and summarizing the findings. So, notations, I think, are discussed in a really effective way within the chapter. There are notations for interaction models, things like diagrams from the UML, things like use case diagrams or activity diagrams and those kinds of things. They certainly can be expressive, and they can be very precise. The observation that the authors have is that they're not going to carry the whole presentation. So if you're going to use these kinds of, say, graphical notations like the UML, it's probably going to be as an element of a multi-part presentation. Stories, to create things like scenarios, are something that that they talk about really favorably. And I've got to agree, I think that when I look across all of the practice areas where I work, the power of story elements to capture what's going on and to convey to other people how we understand the world is really, really powerful. So in interaction design, we talk about scenarios. In systems analysis, we talk about use cases. In agile system development, we talk about user stories. But these are all story-based elements that pull together in a really powerful way the elements of how we see the world. And there just seems to be a lot of power and a preference for the consumers of information to have some kind of a story associated with it. And summarizing the findings is important to do. There's a good discussion in the chapter about how certain audiences, senior executives, for instance, might only be interested in the summarized findings. Okay, and so if we don't have any summarized findings, we're not going to have anything to satisfy that appetite. And there's also, I think, a pretty good discussion of making sure that when we summarize findings, that we don't really come to conclusions that are not supported by the data. So, this is a summary slide, and we haven't used up a lot of time, so I'll take a look here. The data analysis that can be done depends upon the data gathering that was done. Yeah, so one of the things that you'll see people do a lot is think about the kind of analysis they want to do before they go and gather the data, right? These are not independent activities, okay? For instance, if we gather all quantitative data, it's going to be hard for us to do a deep qualitative analysis, and vice versa. Qualitative and quantitative data may be gathered from any of the three main data gathering approaches. So for instance, if let's see, the things we had a questionnaire, we had an interview, and we had observation. Okay, so a quantitative, well, all close-ended questions on questionnaires or interviews are going to be quantitative, and some of your observation recordings can be quantitative as well. Qualitative, in a survey or an interview, We have a lot of open-ended questions that are going to have that qualitative kind of quality. And also in recording the results of our observations, we probably are going to be writing up some things that are more prose oriented that are going to lend themselves to qualitative analysis. Percentage and averages are commonly used in interaction design. Okay, so it's these kind of simple descriptive statistics of a quantitative sort are commonly used. The mean, the median, and the mode are different kinds of average. And then over on the qualitative side, we're not going to be just, we don't want to say, okay, we've come out of the quantitative side, now let's just be anecdotal. No, we don't want to be just anecdotal. We want to take the data that we find and we want to fit them into a theory and framework in order to come up with our findings. And three approaches, three theoretical frameworks that we talked about were grounded theory, distributed cognition, and activity theory. And last but not least, the presentations of your findings should not overstate the evidence. Again, if people would like to jump to conclusions that are greater than what your findings will support, well, that's fine. I mean, people do that all the time. They do that because information is limited and they live in an uncertain world, and to a certain extent they have to guess on things. But they should know what they're guessing about and what we have some hard data about. And so we want to make sure that they know after our presentation what they know about for sure, and then if they want to guess beyond that, well, that's a nice activity and they can do it. But we're not going to do it for them. So, having made that claim, I'm going to say bye until next time. Bye-bye.